Thanks a lot. So, good evening, everyone. So, I'm actually going to go a little bit more basic, and I'm going to talk about role of AI and basically what is AI. I want to go more. Everybody when hears AI, they get really intimidated by AI. Something as like something very powerful, something very is going to take over the world, and all these kind of things. So I really want to kind of break it down, and I want to say that AI is something that it's coming and it's a fact and it's coming really fast. So I will tell you that we are since 2016 have entered a new revolution, which is the age of connectivity. We were before into industrial automation, but from 2016 we have entered a new industrial age, which is the age of connectivity, AI, and cloud computing and big data. Now, we talked about AI, but we don't actually talk about the other things because everything is interconnected. It's not only AI. Behind AI is computing power. Our computing powers are increasing almost every 12 months. We are doubling our computing power. So computing power is the base. So the AI itself, the artificial intelligence, is a very old story from 1960s. But we didn't have the right technologies. We didn't have the right tools. But right now, we are just having the right recipe of things working together. So one of the things that you need to understand is that AI is a uh, AI highly dependent on high computing powers. When you are building these artificial intelligence protocols and models, you are really depending on these computing powers, storage powers, and then this is the backbone. And from there, this is advanced analytics that actually goes into augmented reality, cybersecurity, simulation. We talked about these things, and then it goes into another set of industry, IoT, Internet of Things, that are actually capturing a lot of data points. A lot of us are wearing these Apple Watches. A lot of these data is being captured, and this is what we need for artificial intelligence is a lot of data, and that was missing. And now with IoTs capturing all that set of data coming in, and we have the computing power and we have the clouds. That's the right recipe of things coming in to for the future of the medicine. So when we talk about artificial intelligence, we hear a lot of things. We think machine learning, we hear about deep learning, we hear about generative AI. So basically, I just want to give you an understanding that artificial intelligence is a broader term, is one of the oldest terms that is basically less complex programming and computing powers. And the more complex you go, the more deeper you go. So the machine learning is uh, minimal computing power. Deep learning are neural networks, and you have three or more neural networks. And generative AI is a complex model. And the more you go down, the complexity of the model increases, and you have self-learning capabilities. And the way you go up is more simpler models, and these are it requires more human intervention and programming and training. So the AI, we talked about data. So AI is really based on data. So if you don't have data, you don't have AI. So we already talked about we have the right recipe, we have the clouds, we have the computing power, we have the right storage capacities, everything is there. But the main critical point is that we don't have still the right data sets. So so when we talk about data, we talked about a lot of things that we are when we were discussing into other videos. A lot of the discussion was on image-based data. Some parameters were health records-based data, but actually there are a lot of different types of data. There's text-based data, image and video-based data, audio-based data, tabular form of data, time series, which is health records, and then you have synthetic data. And AI uses all of these and it kind of makes sense out of them, and then it creates an algorithm, a pattern recognition. So basically, same thing, in healthcare, we have almost every single type of data. We have voice data, we have imaging data, we have grayscale imaging data, we have color imaging data, we have genomic data, text and linear scaling. So now what AI does is the more richer the data is, the more power AI has to find patterns in it. So for a lot of the data that we have, for us, it's just noise. For us, it's literally noise. We don't understand the patterns in it, or we have a basic understanding of the pattern, but rest of the stuff for us is just noise. But when you give that data to AI, it's actually able to go beyond what we understand and find patterns in noise. So how does AI sees an image. So I'm going to just give you some just brief example. You know, if you take a chest X-ray, it's a grayscale image. AI actually sees that as numbers. So there is 512 by 512 pixels, and each pixel is numbered as per the gradient of the grade. If it's lighter, it would be less number. If it's darker, higher number. So AI is just seeing an X-ray. We kind of understand that it's actually looking at something. No, no, no. Completely different way of looking of data. So X-ray is just a numpy, is basically a grid of numbers for an AI. And actually it will go through it. It will not make any sense in one X-ray, but when you start feeding tons of X-rays and you start feeding information, then it starts making sense out of it. Okay. So different types of data. So this is a color image data. You know, a color image is made up of red, blue, and green. So it's basically the same thing as grade scale data, but here you have three different grades. You have red, you have blue, and you have green. Again, more richer, the more rich the data is, the more meanings it has in it, the more AI can play with it. So again, if you look at the patient records, you know, we look at patient records as a name, age, gender, and height, or blood pressure, or whatever. AI does not look at that. It looks at as a numerical vector. For Alex, it is a 390178. Pat is 241165. So I just want to give you an understanding that AI is it's a very basic numerical pattern recognizer. And actually, the more data we have, the more accurate data we are able to give it to AI, the more surprises we will get from it. So I'll just give you a basic understanding. You know, in normal traditional computing, we have input data. We give that input data some formulas or some rules, and then the input data goes through these formulas and rules, and then it kind of gives you the output. Yeah, this is traditional computing. The AI is the other way. So what you do is you have input data, and that could be raw data, it could be X-rays, it could be pathology slides, it could be anything. And then you also have the output, and that's the ground truth. And you ask the AI to figure out what is the rule or what is the formulas behind it. And this is how AI learns. So you need to understand that AI needs a ground truth. AI needs some factual information that it can use to learn beyond our imagination. And I'm going to give you some examples. So this is again the same thing. You have an input data, you have a neural network, which is way more powerful than our brain capacity. It gives an output, but that output we're giving him a ground truth. We are giving him this is squamous cell carcinoma, this is lung cancer, this is what and then what it does is this is X-ray. It compares the ground truth, and then it kind of readjust it. It's going to go back, do it again, go back, redo it again. It reshuffles it back and forth until it figures out the right formula, which is able to give you the maximum information. So I'm going to give you an example. Actually, this is one of my projects that I actually did. I was a fellow at Yale, and we have a clinical dilemma that we face that thyroid, sometimes they have an adenoma. And thyroid, behind it, there's another organ system which is called parathyroid. Now, these two organ systems, they are so close to each other that we are not able to tell them apart. So when we do an FNA and we find something in the thyroid and parathyroid, if you look at them, they look exactly the same. The cytologists are not able to tell them apart. So because we see majority of the lesions as thyroid, so we call them follicular adenomas and not recognize that this could be a parathyroid adenoma. So what I did was I actually found parathyroid lesions that were later resected. And then I had a confirmation that this is a parathyroid. And then I went back and I found the cytology slides. These is pathology slides of the cells of these parathyroid adenomas. And I trained the model. So this is one of the papers that we published. We trained 45 cells each. I only have binary classification here, parathyroid and thyroid. That's it. Simple, basic classification. And I'll train 45 cells, and I trained the algorithm, and I tested them on around 2,000 cells from different cases. And I have given them two different classifications. The parathyroid was pink, and the follicular adenomas were brown. And you will be surprised. Case-based and percentage, case-based classification, the sensitivity 100%, specificity 100%, positive predictive value 100%, negative predictive value 100%. This is something the human eye cannot see, but this is two different organ system. when I gave it to AI, it was able to find something in that data that I cannot tell you. This is a black box that I cannot tell you what, but it is able to classify the two binary and was able to give us 100% differentiation. So with this basic example, we already talked a lot about the clinical utilization of AI. Again, you need to understand that wherever there is a rich data and more structured data, that's where AI is going to enhance much faster. So that's why radiology is much more growing faster. Now we have image-based ophthalmology data. All these image-based data are evolving much faster because we have rich data and we are able to process them and throw AI on it to predict patterns. So again, AI is much faster. You know, when we are doing something as a human beings, if it's repetitive, we tend to lose our focus, we tend to lose our accuracy. AI never gets tired. It is extremely fast and is extremely accurate, and it can work 24 hours without any effect. So again, when we use these effects of AI and use it in repetitive tasks like reading the X-ray reports, triaging X-ray reports, or helping us in clinical decision making, it does an amazing work. So again, I talked about the clinical applications of AI. You see that majority of the clinical applications that we so far talked about are AI image based. And again, the more richer the image, the more faster the results. So grayscale image versus color images in pathology and fundus for photographs. We were able to see much more stronger results and more accurate and much more final diagnosis versus less rich data. So again, AI is helpful in image analysis, interpretation of lab results, risk assessments and predictions, and clinical decision support. So again, AI is very helpful in medical diagnosis. It assists clinician in diagnostic support by summarizing clinical summaries, by bringing out all the relative information that you need at the time of decision making, so that all the points that you need at the time of decision making are right in front of you. It can help you analyze and summarize patient data and provide a timely and accurate diagnosis. Again, pathology is one of the major areas where AI is really enhancing uh, fast because of number one, the data is color and rich data, and it has a lot more features that a human eye can identify. I just gave you an example of thyroid and parathyroid. When we're looking at cancers now, when we put those cancers in under the AI, and we give them ground truth of survival prediction, or we give the ground truth of genomic mutations. The the AI is able to find patterns in that histology image and will give you accurate survival prediction, which is very surprising. Like a human eye cannot look at a section of a slide and tell you how long this patient is going to live. We are able to tell this is invasive carcinoma or the characteristics of invasive carcinoma, but we cannot tell how long this patient is going to live, or we cannot tell in majority of the cases what kind of mutation this slide has. But when we put these images and we give them the ground truth of survival data, it is able to predict from these colored images survival. Or when we are able to put genomic data in front of these colored pathology images, the AI is able to predict genomic mutations in these. So it is revolutionary. It is moving really fast, and I cannot really cover the details of it, but I just wanted to go and give you flavor of everything. Again, radiology is one of the areas that has actually structured their data very early. So that's why they are one of the leaders. DICOM is one of the ways they are able to structure and have a metadata. It's not only about the data, you know, the image. The image is organized a certain way, and there's a metadata embedded in one of those files. And that's why DICOM is one of the ways. And now almost entire medical industry is moving towards DICOM because it is structured, it is standardized, and now we are able to move faster. Radiology has done that almost 10 years ago. So that's why much faster. They are doing miracles with their images from fracture detection to tumor detection to you just name it. And I'm going to just give you one more example of radiogenomics, a new emerging field that is happening right now is the very high resolution MRI scans of brain tumors. And by analyzing and feeding these scans to AI and giving the ground truth of genomic data, the neural network is able to predict what kind of mutation this tumor has from the MRI data, not even from the pathology images. From the MRI, you are able to predict mutations in tumors because of these AI analysis. So this just gives you, how things are moving fast and they are just revolutionary. So again, a lot of the speakers talked about risk prediction and stratification. This is a very powerful tool and a very simple tool. This does not the only it needs it needs a good structured data. Linear data is one of those. And now cardiology is really utilizing it for they have wearables. We have these devices that we put on the patient. They put and then they stay for 24 hours or 48 hours, and then they come back and the AI analyze that data and are able to predict a lot of things that we as a human being cannot see. So again, application of AI in cardiology is really improving a lot, especially because of the variables, and are able to connect multiple different modules of data together. So you can linear data with image data and ECG data combined together, and the AI is able to find some new forms of diseases that we were not even sure. So these are the new ways of how AI is really helping us moving forward. Again, in ICU, one of the greatest sepsis. Sepsis is a great indicator. Uh, I'll give you an example of is a we have a tool that is available is CBC. It's basically you take a red blood cells or you take a volume of blood and then you pass through a detector that actually checks each and every cell that is moving through it, and then it gives you an average. So when you look at a CBC, you get an average. Hemoglobin is 12, white cell count is this, but there is a lot of data that is hidden that we don't see and we don't understand. Is what is the pattern of each cell? Every single cell moving, there is a data creating from it. And then the AI, when you put that data of every single cell measurements, the neutrophils are getting plumpier or neutrophils are getting smaller, and that data is able to predict amazing things from ICU patients. Because when they're getting sick, the neutrophils are being produced, they are more plumpier. Initially, they are more smaller, but then they become more plumpier. And then many things are happening that we don't even know. We look at a neutrophil, we just look at a neutrophil. But the machine is analyzing that data, is micro calculation of each neutrophils, and that all together is able to predict sepsis, able to predict mortality, able to predict recurrence of disease, or a patient will return back to the hospital or not readmissions. So just amazing things. So again, the entire time I'm talking about is the main game behind AI's data. And you will be surprised that AI, 30% of the world data is actually produced by healthcare industry. And but unfortunately, a lot of these data are sitting in silos. They're sitting in silos that do not communicate. We're not able to extract it. And 80% of the healthcare data is unstructured. So this is we have miracles coming out of this AI, but with this limitation. But just imagine what's going to happen in future. Okay. So with this, I'm going to just switch my gears a little bit, and I'm going to talk about one of the largest powerful model AI tool that everybody talked about is language model. Large language model is a massive, complex AI model that is self-learning, and it adopts to changes, and it has a behavior. It has a behavior. It has an understanding, and just like I would like to give an example that I was sitting in Johns Hopkins in one of the conferences, and we were attending. The world leaders were sitting there, and we were discussing difficult cases. It was the end of the day, and we had one expert who was known for his solving the puzzle of the most difficult cases. And then we were discussing like most difficult cases. And one of the audience asked, Dr. So and so, how are you able to solve these difficult cases? And the answer was surprising. And the answer was, he said, I do not release any case unless I Google the case. So just imagine, this is a world expert, and he's saying that I do not release or finalize most difficult cases, rare cases, unless I Google the case. And then he said, I find surprises, information that I cannot. It just broadens my thinking. It just gives me extra pieces of information. So just like Google, this is a second level of Google. And you need to understand that these language models are not something that people come to me and say, can I use ChatGPT? Should I use Gemini? No, use one and learn it and understand it. You really have to adopt. Just like not everybody can Google. It's very difficult to Google something. It takes the time and effort and understanding of the language and skills, and I'll talk about it. But take one model, master it, understand it, and stay with it. So one of the greatest utilization of large models is the ambient clinical intelligence. So it is coming in right now. A lot of people are using it, and now the new EHRs, the hospital information systems, they will have built-in ambient clinical intelligence. What is ambient clinical intelligence? Is basically a large language model that listens to the conversation between the clinicians and the doctors, and he captures all that information, and then there's a framework behind it. It transforms all that information into clinical history, past medical history, and converts that into full clinical documentations. Again, this is one of the most difficult areas of healthcare is clinical documentations, and this is how a large language models they really will revolutionize the practice of medicine in future. Again, so I want to start with the large language models, and I want to tell you what is prompt engineering. And we had a lot of discussions in the earlier sessions, and prompt engineering is. So I want to go more basic. I want to give you an understanding. Large language models, they are sitting on an ocean of text. So you need to understand that these models are sitting on the entire World Wide Web data, zettabytes of data. The gigabytes do not work, zettabytes of data. And you are fishing for a piece of information from that zettabytes of ocean. So you really need to understand that that's a difficult task. It's not going to happen by just easy way. You really have to struggle. You need to find a way. You need to learn how to extract data from this ocean in a proper way. So that's why I'm going to introduce you some basic techniques. One of the ways that you extract data, just like we learn how to Google, we learn how to prompt. Now, prompt is basically extracting the large language model, instructing it to go search for this piece of information. So prompt is basically a questionnaire or question or instruction given to AI, and prompt engineering is basically designing an input to influence the AI behavior and output. In medicine, you need to understand that a vague prompt is basically an unsafe, it can give you an unsafe answer. So prompt should be detailed, structured, reliable to give you a reliable clinical answer. So prompt is, when you're prompting, understand that as if you're writing a clinical report or an MRI a report. So the more information, the more comprehensive, the more contextual, the more details you're able to give to that prompt, the more you're able to extract from it. Okay, so everybody said we are using it in clinical education, but we are also using it in the clinical setup, in clinical discharge summaries. Summarization is one of the easiest ways that the AI is used in clinical diagnosis, helping in diagnosis and formulating differential diagnosis. We are using it for patient education, triaging, and research exploration. Again, understand that a good prompt can be life-saving in healthcare, and it's a very powerful tool. So a good prompt has a good, it's a number one, it is detailed. It has a good instruction. It has a meat to it. It has summary. It has suggestions. It has clinical context, background, patient age, history, symptoms, and then even not only that, you can even suggest to give a specific format. Like in medicine, you use a subjective, objective assessment and plan. The clinical notes are all SOAP-based, so you can ask the clinician based on that, give me a structured output, a table output, or whatever you like. Again, another way of helping AI is giving a role assignment. A role assignment, basically, what is it doing? It is basically asking the AI or the to focus on that particular area and go into that field. The role assignment, how it helps is actually when you say act as a radiologist or act as an internal medicine or act as a nephrologist, is basically asking to go and search only the text that is available under nephrology uh, paradigm. So it kind of helps you narrow down. Again, everything that I am telling you, you will hear cheat sheets. You will hear Chat GPT cheat sheets. You will hear many things. I'm telling you, the summary of all of it is you're searching on an ocean or a specific piece of information. The answer is how specific can you get? And all these cheat sheets, all they're providing you is just teaching you how to become more specific to get to the right piece of information. Okay, so there are different well-known types of prompts. Zero shots prompts are asking a very specific question: what are the symptoms of hypothyroidism? Straightforward. And then few shots are more like examples of things that are can be easy and straightforward. But here in medicine, majority of the prompts are chain of thoughts or tree of thoughts, tree branching, or role-based prompting. And this is why, because it gives more clinical context. Everything that is happening, you're providing more clinical context and the more information. And then this is how the GPT or whatever the LLM model you're using is able to give more clear instructions. Again, we talked about hallucination. We talked about AI is not trained to give an answer. I don't know. This is one of the things that is very dangerous. Now, if you give a contextual and detailed information, it is very unlikely that the LLM model will give you a wrong answer. I don't blame the LLM model for it. I blame the user for not using the right prompts. If you are so I for the sake of layman, I really tell people have a conversation. Whenever you're starting a new chat, number one, do not start a chat under your old chat. Like you had an email sent or something sent in the last. No, start a new chat. Start with basic information. Start about if we are asking for hypertension. Ask for what is hypertension? What are the big organizations that talk about hypertension? What are the books that talk about hypertension? Any latest article on? Now you have automatically created a base, a small brain set for the chat. Now, when you go further, it will focus on the previous discussion that is happening in that chat and will retrieve information from there. So instead of using these fancy terms, zero shot, few shot, chain of thought, or tree, basically what I'm trying to tell you is that each chat is a brain and you have to build that brain. Do not ask a clean blackboard to answer you. Build that blackboard to have some information so that when you go and ask a complex question, it will able to give you the right answer. So this is just to give you an examples of zero shot. It's just very simple, straightforward example. What are the symptoms of hypothyroidism? It is good for well-defined examples, time saving. Few shots are when you have it is very good to give an example of input output. Give an input, you say this is, and what is the most likely output. You say this is the clinical terms and I need a translation for it. I need so it is very useful. Few shots are used for patient education and support tools. Now, chain of thought is a very powerful tool that is in medicine. I really believe that if you are clinically practicing it and you're using clinical decision support, this is the way you should go. As I give an example, a new chat with series of questions about the basic subject of that subject. You haven't asked the question yet. You're basically giving a series of information about the subject. Once all that information has been collected, now you go to specific questions and you are, so that the brain of that chat has been built now, and now you're able to ask a more clinical relevant, a more sophisticated, and you are able to get a right answer. So example is the patient is presenting with fever, neck, stiffness, photophobia. What is the most likely answer? Think step by step, give clinical reasoning, give me an article that is or a URL, full URL address of that article that actually explains this, or give me a sources of what you're using, things like that. So this has kind of enhances the explainability, and it mimics like human reasoning. So you just have to understand that you want to treat that brain like a human and talk to it like a human and build it up, and then go and ask him, dive down in the ocean and give me this information. Okay, so another very powerful tool is a tree of thoughts. Tree of thoughts, when you are considering multiple scenarios, you are very not sure about what could be the possibility of this. You have trees, so you can start a tree of thoughts. You can ask multiple diagnostic pathways simultaneously. You can ask the AI just to initiate a train of thought. is three specialists. You can say a radiologist, sorry, a nephrologist, an oncologist, and they're talking and they're discussing this case, and they are discussing this scenario. Can you give me all the scenarios or all the possible pathways that can be taken? So again, another very powerful tool that is very helpful. It explores multiple branching possibilities. It goes into is it MI? It is pulmonary embolism. It is just a muscle pain or costochondritis or a pneumonia. So a tree of thought is another very powerful tool that again is very helpful in clinical persona or role play. Another very easy way of asking the chat or the LLM to focus on a very specific area. So this is another very easy way to act like a radiologist or act like a gynecologist, or is basically all is doing it is just focusing that go on this specific area and focus on that and give me information from this field. Now, we talked about a lot of people have talked about contextual or retrieval augmented generation. This is customized GPTs. Customized GPTs can be done paid versions that you actually create a separate channel, and in which you give contextual information. You can it could be a PDF file. It could you can download pages of worth of information that this is my basic framework. I want to think on this way. This is the PDF. Go through it, or I want only these organizations that you want to focus on. You have, or if you're working on I'm a pathologist, so I work on College of American Pathologists. Just focus on College of American Pathologists guidelines, and that's my. And now when I don't have time, I just go. It already knows that I'm a pathologist. I'm focused on this. I already have all the guidelines, and I just ask the question, and one shot gives me all that. I don't have to build that brain in that chat. It's already built. If you don't have the paid version, the other way of doing it is you build a new chat, free version. Again, you have to do that every single time, or you save that chat. So every single time you have to come back to it, you just come back to that particular chat that the RAG is there. Retrieval augmented generation has already existed, and you just go and ask that particular chat. So you have two different ways of creating RAGs, either through specified customized, or each channel, you create a new channel and you attach or give all that information. So just give you an example how healthcare works. Just to give you an example, like a prompt track, use CDC 2023 COVID guidelines, and you give them the link for it and say, summarize the updated isolation recommendations. Again, what you're doing is I didn't even attach a PDF. I didn't, but I gave him a specific piece of information or website, and I asked him to go down and give me information. So now it is not lost in the ocean. It is going to very specific particular piece of information, and it's going to generate that data from there. So it is grounded, it is updated, and it is much safer. Again, this is something that everybody should understand. This is one of the most powerful tools that we can use in medicine for the LLM models. So with this, I just want to give you that the best practices are for prompting is understanding that you are fishing in an ocean, and you need to be very specific. So always define the clinical context, provide the relevant clinical history, demographics, symptoms. You will be surprised when sometimes you give extra piece of information. I had a clinical history. I was presenting, a patient was HPV positive, and I was discussing the possibility of cytology of this case. And in the clinical history, I had this patient is taking steroids. Now, in my mind, there was nothing. Like, patients taking steroids have nothing to do with pap smears. But suddenly, the chat found that patients on steroids tend to have a higher HPV volumes, and they are not cleared by themselves because of the lower immunosuppression that is caused by steroids. This patient was a lupus patient and was taking constantly. So completely different picture by just having an extra piece of information, and my reporting has completely changed. So I just want to understand, you will be surprised when you give extra pieces of information, you might be able to find something that you will be surprised yourself. So assign a role, again, assign a role, give it an educator, clinician, or a researcher. Use step by step. You can use the tree of or again, multiple discussions. It will really help in coming up with the thing. We already talked about use RAG. RAG is basically another way of customized GPTs, and it is very helpful to actually, one of the very powerful tool is to suggest the output. So just like we have a lot of input data, like we are suggesting as a radiologist, we have a lot more output formats that are well defined. specific radiology like AJCC reporting, SOAP reporting. Every organization has their output formats that are well designed, they are structured. So use them. In my pathology field, I say, give me the report in AGCC format. So it really knows. It's a very complex. AGCC is very complex. It goes in, it extracts AGCC template, and it gives me the report in that way. Again, this is another very good way of structuring and giving extra piece of information to the GPT or the LLM that you're using, and it will help us get the right information. Okay. One last point, and this is something very interesting, and I'm almost done. This is my last slide. There is an effect of GPT or LLMs on your language. If you are not a native English speaker, there is a problem. You really need to understand that LLMs are not meant, they are not designed for people who are not native English speakers. Majority of the LLMs were designed, majority of the data that is available, majority of the data that is available is in English. So this is to give you an example, breaking the program language barriers by multilingual prompting. By this is how empowering the non-native English learners. This is one of the study, and if you guys are interested, please review it. This is three different languages, and they were giving a problem, and this was the problem, and only 42 out of 27 were able to solve the problem by using English. In this second problem, 26, only 15 out of 26, and in the third problem, 12 out of 14. Again, the reason I'm telling you is that using your own native language or multiple languages, like using Arabic frequently in your prompts, and then using the medical jargon in English, it really helps you communicate much more efficiently than finding and forcing your way in English. So again, this is a very powerful thing, and I have noticed this. I actually teach students, and I encourage them to use LLMs, and I realize that the some of the students have very difficulty in kind of utilizing it, and then I realized that difficulty was in the language. So again, you need to understand that. Uh, be very open about using your native language in LLMs. Again, there are multiple papers who are constantly saying that this paper was just published in April 7, 2025, and there are other papers as well. They're saying that for native, non-English natives, there is a difficulty in the modeling or prompting, and you really need to kind of use your native language and use multilingual prompting. And with that, thank you so much, and I hope you enjoyed.